Okay, so today we start with problems of KC, calculations, and numericals. Okay, एक प्रॉब्लम मैं आपके सामने प्लॉट करता हूँ. एग्जामिनर कह रहा है कि फॉर द फॉलोइंग equilibrium H2 gas plus Cl2 gas 2HCl, राइट. ये मेरे पास इसकी इक्वेशन आ गई. इन ए कंटेनर of volume 600 cm cube. They were initially 0.5 moles of hydrogen and 0.6 moles of chlorine. At equilibrium, there were 0.2 moles of HCl available in the vessel. Find its Kc. हम इसकी Kc find करते हैं. तो we can make ice table. Ice table is what? Initial concentration, change, moles at equilibrium. Concentration rather moles. Because हमें भी इसने फिलहाल क्वेश्चन में मोल्स दिए हुए हैं, concentration हमने खुद कैलकुलेट करना. We have hydrogen, chlorine and HCl. There were 0.5 moles of this, 0.6 moles of this, and there was nothing by the start. But at equilibrium, what change is coming? The change is 0.2 moles of HCl. Now, if this is the change which is coming, so we have to look into the stoichiometric number, that what change will happen over here. पहले moles find करते हैं. If I look at the equation, there were 2 moles of HCl produced from 1 mole of this. So if it is 2 moles at equilibrium, so the change in the reactant will be 0.1. Because now see, 1 mole of HCl, hydrogen produces 2 moles of HCl. So if zero point 0.2 moles were there, so X moles of this, so this become 0.1 mole of HCl, which would have been used up during the process. and acting as a change. देखो जब भी रिएक्शन शुरू होता है, the concentration of reactant decreases and concentration of product increase. तो यहाँ पर प्रोडक्ट तो उसने बता दिया मुझे 0.2 कि 0.2 मोल्स होगा, तो मैं कह सकता हूँ दिस इज plus 0.2. That means this is being added up. There was nothing by the start, but now this is 0.2. So if this is 0.1 according to stoichiometric calculation, this should be, chlorine should be minus zero point 0.1 as well. That means 0.1 mole of chlorine is also being used up. So what is the equilibrium concentration of both the reactant and product? This will become zero point 0.5 minus 0.1, 0.6 minus 0.1, and this becomes 0.2. तो अगर मैं इसका सम कर लूँ तो this becomes 0.4 and this becomes 0.6 and this remains 0.2. So these are the moles. But remember, whenever we do Kc, we deal with concentration, not with moles. So expression appear like this. But right now I need to find out concentration, equilibrium concentration. These are equilibrium moles. So how can I find the concentration of this hydrogen, chlorine, and HCl? So for concentration, I have a formula. N is equal to C over V, right? These are equal to, I think I have written it. C is equal to N over V, moles, and volume of the vessel. What was the volume of vessel? So I have to this take this in DMQ. So concentration of hydrogen, H2, moles of hydrogen 0.4 divided by 0.6, because if I convert this 600 cm cube into dm cube, this becomes 0.6. How much this would be? 0.67 mole per dm cube. Similarly, इसको देखो, this becomes 0.5 over zero point 0.6. So this becomes 0.83. And what is the two moles of product? 0.2 over 0.6. So this becomes 0.33. So if I apply these numbers, plug in these values, particularly these, my expression will be, let me write it on the next page, Kc HCl power 2, because there were 2 moles of it, hydrogen, chlorine. So this becomes 0.33 is the concentration of this, power 2, 0.67 power 1, and 0.83 power 1. You don't need to write power 1. So please calculate this. How much this would be? Shabash beta, and that becomes 0.19. So now examiner will definitely ask what would be the unit of this. So Kc was mole per dm cube of HCl power 2 over mole per dm cube for hydrogen and mole per dm cube for, so there will be no units because everything gets cancelled in this case. I hope this makes sense to you, how I have driven the entire question. Please respond me in the chat box. Yes, I'll be doing one more example to make this even more clear. This is the most repetitive question. Examiner is asking for the following equilibrium N2 plus 3H2 to NH3. Initially, there were 1.5 moles of nitrogen. Again, see, it is talking about moles, not about concentration. And 4.0 moles for hydrogen in a flask of 1.5 dmq. अच्छा जी, अब कह रहा है at equilibrium 30% of nitrogen had reacted. At equilibrium 30% of N2 would have been reacted. ठीक है. So what were the total mole of, अच्छा मैं बात यूँ शुरू कर लेता हूँ, पहले Kc की एक्सप्रेशन बना लेते हैं. Kc for this case NH3 power 2 N2 H2 power 3. ठीक है. Now I is table for it. Let me make two columns so that we can do a lot of things which are to be done. First of all, working out to find moles of nitrogen used. Examiner said 30% of it. So what is the 30% of the total mole of nitrogen? 1.5. So how much is this? It should be 0.45 moles. Thank you. So they would have been reacted. So let me make I stable, and I have to do a lot more calculation for this. This is nitrogen, hydrogen, and NH3. Initial change and equilibrium. So initial moles of nitrogen were 1.5, and the change that is coming is 0.45, and this change is negative minus. So 1.5 minus 0.45, this becomes 1.05. तो नाइट्रोजन के मोल्स तो मेरे पास आ गया, अभी ये कॉन्सेंट्रेशन नहीं है। अच्छा, अब एक चीज सोचो कि जितना नाइट्रोजन इस्तेमाल हुआ है उसी पॉइंट ऑफ व्यू से हाइड्रोजन इस्तेमाल होगा। नाइट्रोजन और हाइड्रोजन का रेशियो 1:3 का है। सो 0.45 moles of nitrogen. If 1 mole of nitrogen react with 3 moles of hydrogen, so 0.45 reacts with X. How much this would be? जरा बताओ। It will be around less than 1.5 moles. How much is this, beta? It would be 1.35 moles. This is the change. The total moles were 4. So 4.0 minus 1.35 is equal to around 2.65. And according to the same, if 30% of nitrogen is used, 0.45 moles of nitrogen is used, so I can calculate how much ammonia would be produced at equilibrium. So I can look at the equation: 1 mole of this, 2 mole of that. So 1 mole of this, 2 mole of that. So 0.45 moles of this is to X. How much this would be? This would be double of this, 0.9 moles of this. So this was 0 plus 0.9, so this remains 0.9. So I have got the moles. Now I have to find the concentration. For concentration, I need to know the volume of the flask, which is about, for concentration, because I need concentration for the main formula. So this becomes 1.05 over 1.5 dmq. So you'll get the concentration of nitrogen. For hydrogen, this would become 2.65 over 1.5 dmq, and for ammonia it becomes 0.9 over 1.5. So what are the numbers that you will get? This will become, my calculator says it is 0.7 bmq. This becomes 1.77 mole per dmq, and this becomes 0.6 mole per dmq. So applying this in the main, ammonia 0.6 mole per dmq. So 0.6 square, 0.7 power 1, and 1.77 power 3. So how much this would be? At least two like significant figure. Let me do it. 0.9 तुमने कहा है, 0.06 power 2, 0.7 power 1, 0.927 is the Kc value, and if I find the units for this, so it will be mole per dm cube square, mole per dm cube power 1, and mole per dm cube power 3. So entire of this cancels this. The unit become 1 over mole square dm6, or I can write, or इसको ऊपर ले जाते हैं तो this becomes mole inverse, और ये पहले यहाँ ऊपर आया फिर यहाँ ऊपर जाएगा, तो पहले नेगेटिव हुआ बाद में पॉजिटिव हो जाएगा. dm6 are the units for this. Now okay, so we have seen two of the problem. I hope this would have clear like given little more clear meaning about this thing. अब जरा कुछ कंडीशंस देख लेते हैं और उसके इम्पैक्ट देखते हैं. Effect of changing conditions on value of Kc. ये देखते हैं Kc की वैल्यू से हमें क्या क्या बातें बता सकती है. पहली बात, if Kc is larger, value means more products are formed compared to reactant, right? ये पहली बात. Okay. अब यहाँ एक बात याद रखो, Kc, point number 2, only changes when the temperature is changed. ठीक है, जब टेम्परेचर चेंज करोगे तभी Kc चेंज होगा. नो चेंज बिकॉज ऑफ प्रेशर. ठीक है, इसमें प्रेशर के चेंज से कुछ नहीं होगा. एंड इवन नॉर विथ कैटलिस्ट, राइट, नॉर विद द कैटलिस्ट. ओके, तो अब जरा जज करते हैं कि टेम्परेचर कैसे अफेक्ट कर रहा है। देखो, both the things, both the factors, जैसे position of equilibrium, first position of equilibrium and value of Kc will change if temperature is changed। दोनों बातें ध्यान में रखना। अब इसकी मिसाल से बताते हैं। If the temperature is changed, both position is affected and Kc value, obviously the position को affect होगा। ज़्यादा रिएक्टेंट की बजाय कम रिएक्टेंट, सॉरी, ज़्यादा प्रोडक्ट की बजाय कम प्रोडक्ट फॉर्म होना शुरू होगा या रिएक्शन बैकवर्ड को फेवर करने लगेगा, तो Kc की वैल्यू ऑब्वियसली चेंज हो जाएगी। एंड दैट डिपेंड्स ऑन द प्रोफाइल ऑफ रिएक्शन। हमने ली चैटलियर में पढ़ा था कि इंक्रीज इन टेम्परेचर फेवर्स द एंडोथर्मिक साइड ऑफ द रिएक्शन ओनली। तो उसी बेसिस के ऊपर यहाँ पे चेंजेस हमें नजर आएंगे। ओके, अब जरा देखिए, एक मिनट। ओके, now example is nitrogen reacting with this makes 2NH3, and I know that this reaction is exothermic, and if this reaction is an exothermic, if I increase the temperature, if this is exothermic, so this must be endothermic. So increase in temperature favors backward reaction, और अगर बैकवर्ड रिएक्शन फेवर हो रहा है तो मोर रिएक्टेंट्स विल बी ऑब्टेन्ड इन द वेसल, और जब रिएक्टेंट ज़्यादा होंगे देन Kc वैल्यू decreases। If the temperature is decreased for this reaction, it can be applied on any case, like हमने तो अभी तक इसी को डिस्कस किया है। If the temperature is decreased for this reaction, so it favors forward reaction, more product will be formed, so Kc value increases। ठीक है बेटा, तो ये तो वो फैक्टर्स थे। ओके, अब एक और कोई मुख्तलिफ किस्म का प्रॉब्लम अटेम्प्ट करते हैं। अब ये क्वेश्चन मैं फ्रेम करता हूँ फॉर द फॉलोइंग। दिस इज एग्जाम्पल नंबर 3। इक्विलिब्रियम H2 प्लस Br2, इसी एग्जाम्पल को ले लेते हैं। इक्विमोलर का केस है, दोनों के इक्वल मोल है, बट द प्रोडक्ट हैज, इस हिसाब से भी रिएक्टेंट प्रोडक्ट को देखो तब भी इक्विमोलर है। Examiner is saying 0.2 moles of hydrogen and 0.2 moles of bromine are mixed and allowed to reach to the equilibrium, right? इसको अलाउ किया कि तुम इक्विलिब्रियम, इफ Kc value is 0.210 with no units, because you can see there are 2 moles of reactant and 2 moles of product, so both cancel each other, so no unit for this Kc. If Kc is this, calculate the equilibrium amount in moles of each substance. सारे substances में focus करना पड़ेगा। चलो, just give me a minute, let me have a glass of water. Okay, you must have framed something about the question. See, I'm not given with the volume. Okay? I'm not provided with the volume, and I have to do this question upon the basis of mole, considering अच्छा जो वॉल्यूम रिएक्टेंट का होगा वही वॉल्यूम प्रोडक्ट का होगा। So Kc HBr power 2 and Br2। आई थिंक मुझे कॉलम कर लेता हूँ ताकि मुझे लग रहा है ये कुछ लंबा हो जाएगा। I have the value of Kc 0.21, which is provided by the examiner already. अच्छा, मुझे ना तो प्रोडक्ट का अमाउंट पता है, मुझे इनिशियल मोल्स तो इनके पता है, ओके। मुझे एच बी आर का कुछ भी नहीं पता है, बस मुझे के सी वैल्यू दे के, इनिशियल मोल दे के, फाइनल मोल्स या कॉन्सेंट्रेशन के बारे में पूछा जा रहा है। आई डोंट नो अबाउट दिस, सो वट एवर दिस वुड बी, जो भी हाइड्रोजन के साथ होगा या ब्रोमीन के साथ, उसका ट्वाइस इसके साथ होगा, बिकॉज देयर आर 2 मोल्स ऑफ दिस। ओके, so let us apply. So if this is x and this is x, so this would be 2x. मैं एक्सप्रेशन बनाता हूँ 2x over 0.2, and I know that ये x twice, x वो अमाउंट है जो रिएक्टेंट का खर्च हुआ, 2 minus x and zero point 0.2 minus x because they are in 1:1 ratio. लेकिन मुझे केसी के लिए हमेशा वैसे तो कॉन्सेंट्रेशन का फैक्टर चाहिए, तो सर आपने सिर्फ मोल के ऊपर कैसे बना लिया? ओके, लेट मी री राइट इट। 0.21 वॉल्यूम मुझे बताया नहीं, तो मैंने इसको v कंसिडर कर लिया। 0.2 माइनस एक्स ओवर v and 0.2 minus x over v as well. But as this v is common, so I can ignore that. ये मैं कैंसिल कर सकता हूँ, ठीक है, क्योंकि ये भी स्क्वायर था, तो मैंने v को कैंसिल कर दिया। ओके, अब ज़रा मैं चेक करता हूँ कि मेरे पास बच क्या रहा है। मेरे पास जो बच रहा है 0.21, again I'm left with the same thing, 0.2 माइनस एक्स, और ये मल्टीप्लाई होने के बाद ये भी स्क्वायर हो गया। अच्छा, तो यहाँ मुझे अगर मैं इस एक्सप्रेशन को यहाँ पे छोड़ दूँ, तो एक वेरिएबल में मेरा आंसर यहाँ पे भी आ सकता है, ठीक है। लेकिन इफ आई टेक स्क्वायर रूट ऑन ईदर साइड, just to cancel these squares, I will be left with root of 0.21 is 0.458, and this remains 2x over 0.2 minus x. Now let me cross multiply this. So this calculation goes on this side up. 0.458, 0.2 minus x is equal to 2x. And now if I multiply these two and these two, so this becomes 0.0917 minus, this multiplies with this, so this becomes 0.458x is equal to 2x. Now let me bring all the x quantities on one side. So 0.0917 2x plus 0.458x, right? So if I add these two x quantities, so this becomes 0.0917 and 2.458x, leaving x on this side, 0.0917 over 2.458. So this becomes value of x become, thank you Simra, 0.033. This is the value of x. Now if I remember, I started with I started with what? Mm, this expression. So I should have 2 square of this thing, the value. अच्छा, पहले फॉर हाइड्रोजन, हाइड्रोजन के मोल्स कितने थे? This. So if I replace this x with this, 0.2 minus 0.373, the moles of hydrogen becomes 0.163 moles. And same for this is for hydrogen. और ब्रोमीन का भी सेम था, तो फॉर ब्रोमीन 0.2 minus x, so 0.2 minus 0.373, 0.163. But I have 2x according to equation. So 0.373 times 2 becomes 0.074 moles of this. So I have got individual moles at the time of equilibrium for each of the material that I'm using in this. Is that making sense? I hope so. So one testing problem for the following equilibrium: SO2 plus O2 reversibly producing SO3. If the initial moles SO2 were 0.48 and oxygen O2 0.24, allowed to reach equilibrium where SO3 has 0.2 moles. Equilibrium moles of SO3 were these. So find Kc at equilibrium. Complete all the details for this question quickly. Whomever is watching this video, complete this and send your answer on WhatsApp. Start your work now.